Okay, page 15 starts off with a problem very similar to number 79. This is another binomial times binomial, so I'm not going to show both methods again like I did on the previous video. Instead, I'm going to do the one that I am more comfortable with, which is the double distribution or FOIL method. So we're going to do r times r, which is r squared, r times 4, which is 4r, negative 7 times r is negative 7r, and negative 7 times 4, which is negative 28. Then we combine like terms, and that is the answer, r squared minus 3r minus 28. Okay, number 81 says, consider the quadratic function f of x equals negative 2x squared plus x minus 8. Find the y-intercept and the equation of the axis of symmetry. So this is all coming back to, this is in standard form. Okay, f of x equals ax squared plus bx plus c. Remember that the y-intercept is the point 0, c. So all we have to do here is recognize that a is negative 2, b is positive 1, and c is negative 8. And that tells us the y-intercept is the point 0, negative 8. So there's one of the two answers right off the bat. Now the axis of symmetry, we should remember, is the x-coordinate of the vertex, and it is given by x equals negative b over 2a. So we would say the axis of symmetry is negative b over 2a. X equals negative b over 2a. So that would be negative 1 over 2 times negative 2, or negative 1 over negative 4, meaning that the line would be x equals 1/4 for the axis of symmetry. Number 82 says determine whether the given function has a maximum or minimum value, then find the maximum or minimum value. So, number 82 is in standard form. Essentially what this is asking you to do is recognize whether this opens up or down, and then we have to find the vertex because the maximum or minimum value of any parabola occurs at the vertex. So that's basically a three-step process. We need to identify A, and we're going to need B. We don't really care about C in this case, but again, we should be able to know that C is equal to 5. So since A is positive, and really I should use a lowercase a, so let me fix that. That tells me that this graph opens up, which means I have a minimum value. So that's the first part of the answer, is just look at the sign on A. If A is positive, it opens up and has a minimum. If A is negative, it opens down and has a maximum. From there, I need to find the axis of symmetry, negative b over 2a. So that would be 8 over 2 times 2, or 8 divided by 4, which would be 2. And then I need to plug that value in for x. So I need to find f of 2. So I feed that to my calculator. That would be 8 minus 16 plus 5, or negative 3. So my answer would be minimum value, and that value is negative 3. And that is a y value, so that's why I wrote y equals. Same thing on number 83. In this case, A is negative, which tells me that this opens down. And that means that since it opens down, that vertex is the maximum value. Then I say, okay, A is negative 2, B is 4. I need the axis of symmetry, which is negative b over 2a. That's negative 4 over 2 times negative 2, which would be negative 4 over negative 4, or 1. And then I plug that value in. So I find f of 1. So plug in 1 for both x's. And that would be negative 2 plus 4 plus 2, which would be a value of 4. So that maximum value would be 4. 84 and 85 ask us to factor. In both cases, this would be factoring out the greatest common factor. Both of these we should recognize as greatest common factor factoring. So the first set of stuff here, these are both divisible by 2, so I would factor out a 2. Now remember what that does, and you don't necessarily need to show this step, but in your head you need to go, okay, if I'm going to factor out a 2, what I'm doing is dividing each term by 2. So that would be 5g plus 7h, and that is fully factored. On number 85, we have to consider all three terms. All three terms are divisible by 12. All three terms have at least j squared. We can't do anything with k because this term doesn't have a k. So we're going to take out a 12j squared, which again means that we are dividing each term by 12j squared. So that would be 12j cubed k over 12j squared minus 36j to the 5th k to the 6th over 12j squared plus 12j squared over 12j squared, which makes this an excellent example for review because if we're not careful, we're going to screw this up. So our outside, we have 12j squared. This, the 12 and the 12 divide to equal 1, which means we don't even really need to write the 1, but I will anyway. J cubed over j squared is j to the first and k to the first, so 1jk. Looks like an L, so I'm going to make it into more of an obvious 1. Minus 36 divided by 12 is 3. This would be j to the third, k to the sixth. And then finally, 12j squared divided by 12j squared is not nothing, it's 1. If you forget the 1, you'll get this problem wrong, so make sure you're paying attention. Numbers 86 and 87 ask us to solve. Number 86 is set up already for the zero factor theorem. Remember, if we have two things multiplying to equal 0, that means either the first thing equals 0 or the second thing equals 0. This one's already solved, so we just circle it. First answer is q equals 0. Second answer, we would subtract 4 from each side, and we would get a second answer of q equals negative 4. 87, we need it to equal 0 before we start. So we would start by subtracting 16g from each side. Notice I'm not writing it underneath 20g squared because those are not like terms. So we should just simply rearrange this to say 20g squared minus 16g equals 0. We're then going to factor out the greatest common factor. Those are both divisible by 4 and they both have a g. So that would be, and again, this is what's happening, we're dividing those two terms by 4g. And that would still equal 0. So that would be 4g times 5g minus 4 equals 0. Then we split that into two separate equations. 4g equals 0 or 5g minus 4 equals 0. We're both going to require a tiny bit of solving, although the first one we just divide by 4, and when we divide 0 by 4, we still get 0 as our first answer. Second one, we would add 4 to each side, which would give us 5g equals 4. And then we would divide each side by 5, which would give us g equals 4/5. So our answers are 0 and 4/5. 88 and 89 are asking us to do trinomial factoring. Remember what we're doing here. We're looking for two numbers that multiply to the value c and add to the value b in x squared plus bx plus c. So we are looking for two numbers that multiply to 12 and add to 7. Well, let's look at all of our options, even though most of us can come up with it immediately. There are a total of 6 number pairs that multiply to equal positive 12. And if we add all of those up, only one of them adds up to positive 7. So we would use 3 and 4. When a equals 1, we simply write those two numbers in our factors. So we would have x plus 3 and x plus 4. Same thing over here. We're looking for two numbers that multiply to negative 54 and add to negative 3. So that would either be 1 and 54, or one or the other is negative. 2 and 27. 3 and 18. 4 doesn't work. 5 doesn't work. 6 and 9. And that would be it. Add them up. And once we get good at it, we probably don't even need to show this chart. But it's always kind of nice to see all the work. Negative 3 is what we're looking for. That's positive 6 and negative 9. So G plus 6 and G minus 9 would be my factors. 90 and 91 are asking us to solve again. On number 90, it's already factored. So just like the previous examples, we have two things being multiplied to equal 0. So our answers are given by each factor set equal to 0. So then we would say, okay, either r minus 3 is 0, which means when I add 3 to each side that my first answer is r equals 3, or r plus 6 equals 0, which means when I subtract 6 from each side, I get r equals negative 6. So those would be my answers there. On 91, they have not factored yet. No problem. We just factor. We're looking for two numbers that multiply to 28 and add to negative 11. So again, there's only so many options. Might as well write them all out if we're not sure. There they are. That's every pair of numbers that multiplies to equal positive 28. So we add them up. And we find the one that equals negative 11, which would be negative 4 and negative 7. So this would become r minus 4 and r minus 7 equals 0. Now notice this says solve, not factor. So then we're going to split them up and do what we did on the previous problem. R minus 4 equals 0 or r minus 7 equals 0, one or the other. And then we're going to solve each one of those equations. So the first equation will add 4 to each side, which would give us the solution r equals 4. And the second one, we would add 7 to each side, which would cancel the negative 7 and give us our second answer of r equals 7. On 92, it says indicate the answer choice that best completes the statement or answers the question, and it gives us the equation k squared plus 8k equals 84. Remember that anytime we solve a quadratic, we need to first have it equal to 0. So the first thing we need to do is subtract 84 from each side. So we're going to go minus 84, which will move it to the other side and give us an equal 0. Now that means we're factoring. We're looking for two numbers that multiply to negative 84 and add to positive 8. This means one number will be positive and the other will be negative. 1 and negative 84, negative 1 and 84. 2 and negative 42, negative 2 and 42. Now notice we're getting closer together when we add them together. So it'd be negative 83, 83, negative 40, and 40. So we're not there yet because we need to get all the way down to 8. Let's see, 3 would go in, but it's not going to be enough. 4 would go in, it probably won't be enough. But let's look and see what 4 would be. 4 and 21. Yeah, see right there we're to 17, but we're still not there. So I'm looking at this and I'm thinking it's probably 6. 6 and what is that? 14. 1 positive, 1 negative. Hey, look, there's the set we need. Negative 6 and positive 14. So this would be k minus 6 and k plus 14 when we factor it, which means our solutions would be given by k minus 6 equals 0 and k plus 14 equals 0. We would solve those by adding 6 to the first and subtracting 14 from the second. And we would get our two answers of 6 and negative 14. So we want 6 and negative 14. That is answer C. 93, which is the last problem on page 15, is a trinomial with an a value. So here's how we deal with that. 3g squared plus 8g plus 4. Now we don't just look for numbers that multiply to 4 and add to 8 anymore. What we do is we do 3 times 4, which is 12. And we look at numbers that multiply to 12 and add to 8. Again, the 8 being the middle number. So that would be 2 and 6. Now, it's also different in that those do not go directly into our answer. Instead, what we do is we take that middle term and we break it. So we bring the 3g squared straight down. And then we're going to break that middle term into a 2g and a 6g. 2g plus 6g is still 8g. And now we're going to factor by grouping. So we're going to group the first two terms and group the second two terms with some parentheses and factor out the greatest common factor. So this first set of parentheses, I can take out a g, which would leave 3g plus 2. The second set of parentheses, I can take out a 2, which would leave 3g plus 2. Okay? That means that I now have a binomial, two terms, and they have something in common as well, 3g plus 2. So if I factor that out, that's my first factor. And my second factor is made up of the stuff sitting in front of the parentheses, g plus 2. So it would be 3g plus 2 times g plus 2. That does it for page 15.